In this video, we'll be covering a camera system for a bird's eye point of view video game. Thing you'd normally see in co-op games. Here, this is the basic camera view, and depending on how many other characters there are on the screen, this camera system will dynamically adjust to it. Here, I'm just going to be adding some other characters. They're just some simple characters with like very simple AI. They just move around and then they jump at random times. So you can see that as I keep adding them up, the camera tries to find the average position of taking into account of all the characters on screen, and try to keep its distance to that position. And also you can see that as our player character goes further away from that distance, the camera arm, the camera distance itself, the spring arm basically, the spring arm's length extends. Now let's just kind of the numbers down. It's 2. You can see if I get close to the center of the character's average point, you can see the camera's pretty close up, and then when the character is further away, the camera pans out because the target arm length extends. So here is how the system works. So for this system, you can just use your default third-person character. I have nothing really much going on here. I do have so here from the default camera third-person character, you don't have to worry about this. This is just for visualizing, so it's easier to keep track of which one was the player. I got rid of the spring arm and the camera because we're going to be creating a different actor that's going to be the camera for the game. And here there was supposed to be the camera inputs control events here. Got rid of that. This is just for the text, so it shows up here on the screen like that. So that's pretty much it. Then the main part is creating a camera. So here I have it called BP camera shared camera power stone. So this was actually a video based on like a request from a few months ago, and the person wanted something with the request was to create a camera system similar to Power Stone, so I referenced that, hence the name. But you can call it whatever you want. I just call it BP camera shared camera power stone. And this is an actor that has a spring arm, a camera, and as for the orientation, like the rotation and the position of the camera's spring arm, it's best to just match it to the world. So here, see the x-axis goes up this way. You can see on the screen right here. The y-axis goes this way. And here also in my world, I have the x-axis going this side, the y-axis going this side. You can see here, right? X, Y. So I just kind of try to match them up. So this is the setup I used. Depending on the game you're trying to develop, this might differ a little, but I think you'll be able to get some insights on whatever you need with the local camera system after you after you match it to your game. Okay, that was some blabbling. Never mind that. But yeah, so I just try to match these two up. And here we have just some begin play. We have a function called Initialize targets. I'm not sure if it's it's a custom event. So these 3 are just custom events. You can just put them in functions, I'm pretty sure, but just for the sake of this tutorial, I just kind of place them out here as custom events. So Initialize targets is called on begin play. So basically, as you can see, just go over here. Let's go over the nodes first. Initialize targets. What it does, it takes an array of targets, which is in this case character, because I want the camera to take into account just character classes, the characters of the character class. In any case, if you want your camera system to take into account other actors, like, you know, you can just change the type to whatever you want. And then here, of course, I want the character classes, and I get all actors of the class, the targets, and then put them here. So basically, this is just to kind of help the camera actor, this camera actor, to understand which targets it needs to take into account. So it's called here on big gameplay, obviously, because that's when the game's starting. We wanted to know which ones to take into account, but also while I'm increasing or decreasing the number of characters on the screen, obviously the number of characters this camera has to take into account changes, right? So this is also called when new targets are added. So here you can see in my level blueprint, just for debugging, just for the demonstration purpose, I have it so that when I press V, I just create, I get rid of an actor of the character, and if I press B, I just spawn a different character. This is just mumbo jumbo, so I can just have like random AI, so you don't have to worry about that. So basically, you just have to remember that I call initialize target whenever I add or reduce a target that I want the camera to take into account when it's trying to fit them on this, in its frame. And this is what it does. And then basically on tick, we have it adjust the location and the distance. So let's first go over with adjust location. Here I have a function called get adjusted location, which returns a vector value, and it just sets this camera's location inside the world, which is basically the default scene root. This is going to be the root component of this actor. So it's going to be modifying this this component's world location. And adjusted here. So I have this just for the debugging. Don't worry about that. So here you can see if I add or decrease, you can see these little debug traces. That's what this is. So in your case, if you don't need it, you don't have to worry about it. You just have to connect the execution pin from the start to the end. That's all. You don't have to worry about this. This is just for the sake of debugging. So here, what it's doing is lerping between two vectors. And what are the two vectors? The center points and the player character's location. You see here, the lerp is between, I'm just going to pause this. So lerp is between the center point and the player character actor's location, which is here, this is the center point, and here, this is the player character's location, and it's lerping. So if the alpha value is 0, this camera actor's location will be closer to this, and if it's closer to 1, then the camera actor's location will be closer to this actor's location. So if it's 1, it's going to be the exact position the player character is. If it's 0, it's going to be the exact location of this get center point, which is also another pure function I created. And what's controlling the alpha? How does it control whether it should go closer to the center point or get closer to the player character? This is the game design aspect of this, right? So, because obviously when you're playing a game, if these two are really far apart, you don't want your camera to be staying in this position because it's not going to be framing your player character. You obviously want it to keep the player character inside the frame at certain, as much as possible, I would assume, because as a player, you're more interested about what your player character is doing, right? So yeah, that's how it goes with the lerp, and then it returns that value, which becomes the vector value for where the actor location should be. So how does it know? How does it control the alpha? So here, actually, let's go get the center point first. So center point again. What's going on here is just gonna play around a bit, just to kind of expand the parts. So the center part here, I have it set up so that this black and white debug traces, this is the center point, which is basically the average vector value of the targets it's concerned about. So the three characters. In this case, the camera actor cares about the center, the average position of these three characters. Then that's the center point. So what it does is gets targets for each of them. We add them to a variable called vector sum, which is a local variable in this function. Is it actually just a variable? No. Never mind, but I don't see it. I'm a little confused, but the point is you want them to come and get into a vector sum. You want to add them all up and then divide it by the number of targets, just to get the average. And there might be some cases where you don't want the z value to be accounted for, right? So for example, if I have a character and one's jumping, you can see that the height value is also being taken into account, right? So in some cases, maybe you don't want the camera to be moving up and down, and so in that case you just have to make it ignore z value, and so you can see that it still stays there. I mean, the alpha value is affected here because as the character is jumping, the distance between the center point and the player character differs, obviously, because it's jumping, right? And that affects the alpha value, but you get the idea that if it's like this, the location actually is just fixed on the x-axis. Just gonna cancel that out. Okay. Here we get the center point, and then the bit we put it into A, and then that's how it works. And for the alpha, so here we have a curve value. I like controlling with a curve because while we're iterating on the gameplay aspect of it, we can kind of like tweak it around using the curve. Here we have it like this. Just see how it's moving, right? Then, well, if we just kind of adjust the value, it's gonna here. Inner here. If I move this, you can see how the red part is adjusting. So what this is saying is this value is going to be always, the x-axis is going to be the distance, and the y is going to be the alpha, which is from 1 to 0. So as we control this in time, that's going to be the distance, right? So here, if the distance is at 0, the alpha is going to be 0, which means it's going to be right to the player character. If the distance is, let's say, 1200, and we have it to 1, then that means if the distance between the center point and the player character is 1200, 1200, then the alpha is going to be 1, which means the further away it is, it's going to get closer to this value, the player character. So for what we can do here would be that if the distance is If the player character is closer to the center, obviously we just want it to stay close, maybe to the center point, because even if it's close to the average point, that means it's all the whole frame what might be in like the inside the frame, right? Like all the what do I call it? Like all the important objects that need to be inside the frame would be here. However, if the player character is going further away from it, like I would assume as a game designer, like the action really isn't here. Like if I'm moving further away from it, if my camera is still looking at here, then like I can't see my player character, right? Obviously, I want my player character to be visible on the camera, so that's why the further I go away from it. So here in this point, this would mean if my player character is 1,200 Unreal units further far away from the center point, then the camera is going to be set to my player character's location. It might be a little confusing. I'm to kind of get your head around it, like, because my explanation I know that it can be kind of confusing at this point, but if you just follow these nodes, try them out, I'm pretty sure it's you get the idea. So we'll just need a get adjusted location function, which is a pure function because we don't need to have the execute, we just need a vector value, right? Which gets the center point, in which the center point and the center point is a vector value that gets the average vector of the targets that the camera needs to care about. And then the player character lives between them, and the further away the player character is, the closer the camera is to the player character, and the closer it is, the closer the player character is to the center point, the closer it is, the camera is to the center point. But obviously you can change this up a little bit. So like if you want the player character camera to be further away from the character for whatever reason, then you can just, you know, do it the other way around. And that is the location part. This get adjusted location. And it's pretty much the same principle for the adjusted camera distance, except that this is setting the actor location, this actor's location. This is setting the spring arm's length. So here, I'm just gonna close out it again. I have another pure function called get adjusted target spring arm length, which is another average distance of it. So I have targets, same thing except just using floats. I get the distance between the targets with the actor location of the world location of this camera. I have it subtracted. I have the target's location subtracted by this actor's location, and then I add them all up to a vector distance variable. Then I get the average distance from all the targets to this camera actor location, and the further they are, the longer the arm length. So obviously that means the more characters there are, and the more further away from them, the average distance are away from them, from this part, the longer the spring arm length would be. So here I have the average length here. No, I mean the average center point of all the targets is here at this point. And here we have like characters distance from here, one here, one here, one here, and so on, right? And then this calculates the average distance of all the characters from this point. And depending on that, we again use the camera distance float value, and the further away they are, from the further away the higher the average distance of the characters, the longer the spring arm length becomes. Or we can do it the other way around for whatever reason. We can have this to let's see. Oh, why is this? It's a little confusing for me too. Just a moment. Yeah, I haven't looked at this for some time. Yeah, average distance goes to the x-axis, then this returns the y-axis, which is the distance. X-axis. No. Oh right, I was confused because yeah, this isn't an alpha. That's why. Yeah, that's why I was confused for a moment. So here, the adjust location, this returns an alpha value, and here we don't have an alpha because we don't. The camera spring arm length, we don't have like a set range that we want it to be in, so we just have like a flat value, like just the actual value that we want it to be. So let's say if the average distance is 0, then we want it to be 500. Then as the average distance goes up and up, the higher, let's see it in so here, for whatever reason, if we want the camera to be at a longer distance and then gradually gets closer when everyone's further away apart, we just have to move the curve like this. Pretty cool. Like, I love this use curves. So like we can see like everyone's further away, the camera gets closer, but obviously as is, in a normal game, in a good game, I would say, is something that allows the player to have control over what they want, which means they need to be able to have information on what's going on the screen regarding their the character they're controlling, right? So here, when the average distance is close, we want it to kind of like set the camera distance not too far away from it. Then when everyone's kind of further away from the center point, with this like the this would be like the hot spot, like the hot zone of the action, right? Because in normal cases, in general cases, and then if everyone's all further away from it, we want everyone to be inside the view, which means we would want the spring arm length to increase. Which here we have kind of like adjust this. Maybe you want it to kind of have it in a smoother fashion. So yeah. But the thing is, like, you can simply just maybe arrange map range clam, use like values like this. But the thing is, like, it's kind of annoying when you have to come inside, change the values here, stop the game, compile, play again, and that's just a lot of redundant work. So I think just having some curves, using them like this, it's much easier for iteration. And if you're a programmer, I spend most of my time as a game designer, and as a game designer, usually you'd want more easier ways to iterate and focus on actually finding the right values for certain features, right? So I think these are some things as a game designer you'd like to always keep in mind of figuring out ways to make things easier for the iteration process. I did ramble about some other stuff too, but I hope it helped. And of course, any feedback, any other requests are always welcome. And I will see you again in the next video. Thank you.